So now I'm very happy to introduce our first keynote speaker, a longtime friend and colleague, Dr. Christiana Zenner. She is a professor in freshwaters environmental values and ethics from Fordham University. She earned her PhD in environmental ethics, bioethics, and religious ethics from Yale University, and her BS in human biology from Stanford University. She's an associate professor in theology, science, and ethics, and is affiliated faculty in environmental studies at Fordham University Lincoln Center in New York City. She's a scholar of science and religion, focusing especially on modernity's notions of freshwater and ecological science, environmental ethics, and religious ethics. She's the author of Just Water, Theology, Ethics, and Freshwater Crises. Dr. Zenner is also co-editor of 2 volumes on bioethics, science and society, and sustainability. She's published many peer-reviewed articles, and her public-facing engagements include The Washington Post, The New Republic, MSNBC, TED-ED, and The New York Times, and Public Radio International. In 2013, she was named one of Microsoft's Heroes in Education. Her next big project is an international collaboration on planetary metaphysics through the Berrugan Institute. Please join me in giving a warm welcome to Dr. Christiana Zenner.
Well, good morning, everyone. Thank you, Dr. Tuininga, for inviting me. I'm really honored to be among everyone gathered here today, and especially the students and community partners in both corporate and governmental contexts. Thank you, Dr. Coppell, for your wonderful and value-centering introduction, and to the PSEG Institute for Sustainability Studies as well. The work you are doing here is really cool, and it's been fantastic to learn about. What I'm going to do in the next 40 minutes or so is give you a little bit of a sense of how I come at questions of fresh waters. And as you'll note from mine and my colleague Dr. Hendricks's presentations today, much of the theme that Dr. Tuininga has identified has to do with fresh waters, which, as I like to say, are ultimately intersectional with almost everything. So for those of you whose collaborations and team projects may not be exactly focused on fresh waters, I hope that there is also something in here for you. For as long as I can remember, whenever I've had the pleasure or privilege of flying for work or for fun or to visit family, etc., out in the Western United States, I choose the window seat. I choose the window seat because I'm fascinated by aerial visions of land and light, and during the daytime, by the interplay of water and wind, by the winding ways and spoolings of waters brackish and fresh, and the gathering of moisture into clouds that hover below the tiny tin can that I'm in hurtling through the skies. And one of my earliest memories is of a moment that reframed my world perspective, though I was about 4 or 5, so I didn't know how to describe it at the time. And it's because of an aerial landscape perspective. This is not that image from my childhood. This is an image of the Los Angeles Aqueduct as I was flying out of LA last year. So, despite having been on the East Coast for many years, since 2001, I'm the daughter of Californians. I myself was born in California, and the Central Valley of California, to be specific, which some of you may know and others may not. How many folks here are from more of the Western United States? All right, represent. We'll work on that in the future. It's fine.
We are done.
Well, as Amy said, toilets and fire and hope. Here for it. I think that's a great combination. Okay. So my late father flew jets for the military, and afterwards, for a few years, he flew smaller, slower planes, shuttling agricultural business executives around the Central Valley of California. Now, as the name suggests, the Central Valley is in the middle of the state. It's a semi-arid region nestled between the bustling coast and the water-gathering mountains. And since the 20th century, this has been a highly productive agricultural region for the vast majority of produce grown in and distributed around the United States. The city of Fresno, where I was born, was nicknamed the raisin capital of the world, and I recently learned that 100% of domestic raisins come from this area. 100%. Not a lot of that kind of certitude in this life. So I remember laying out grapes on the sidewalk, for example, to see how quickly or whether they would turn into raisins. And yes, this is how you become interested in environmental studies. So I don't know exactly what I was doing in a helicopter. At age 4 or 5, I've certainly not been in one since. But my best guess is that my dad had a buddy who flew them, and so up we went. And what I do know is that amidst the whirring of the blades and the feeling of jolting lift, I looked out the windows, and what I saw astounded me. What I saw was not the world as I experienced it on the ground. Instead, it was the world of thrumming noise in a helicopter, a feeling of contingency, and a visual of economically productive agricultural regions, as I have later come to learn, as engineers and water rights lawyers and agribusinesses saw it. Parceled, squared off, perfectly 90-degree corners in a checkerboard of browns for the fields lying fallow in their off-season, and then within some parcels, the bright bursting green of perfect circles that signaled the reach of center pivot irrigation systems. And for anyone who's flown across the Midwest or parts of Central California, you will recognize this site. So within the circles of center pivot irrigation, which was developed in the mid-20th century, or really expanded in the mid-20th century, waters unleashed into these arid soils and consumed by seed and transformed into crops with the help of sun, bringing forth the succulence and abundance of strawberries, soybeans, and much more. Now, what makes this landscape possible and economically productive is a congeries of several important conceptual assertions, each of which are important. First, of course, is the idea of land as private property. And as we know, this Western political economic formation arrived with settlers from Europe. The settlers relocated, nice word for culturally eliminated, forcibly removed, and expropriated lands of First Peoples, and then identified land as property that can be parceled, bought, and sold, and cultivated for various, generally economic purposes. It has not always been this way, of course. That's a historically contingent, geographically specific, culturally nuanced story, though it's undeniably globally powerful. And extractive paradigms of this sort and more now characterize much political economy in the United States and globally. So as with the philosophy of property brought from Europe to the Americas by settlers, of which I am definitely a descendant, it's also important to consider the set of concepts that allow water in particular to be claimed and allocated in various parts of the United States. This then is the second set of conditions that have allowed waters to become the kinds of things that foment industrial, agricultural, commercial, and domestic development. The paradigms under which water is designated and then valued vary from state to state in the United States. And in California, I could go on and on about that for a while. I won't, but there are long-standing water rights paradigms that essentially privilege the first in time, meaning the first in settler time, to have those water rights as the ones who are most deserving of continuing access to that water. So we can begin to infer how there are questions of equity and justice that flow from this. If it's simply that the people who got there first get the most right to water, that seems a little questionable in a world of mounting global challenges due to climate change and more, about which I will say more shortly. There's also a privilege given both in the west of the United States and in parts of the east to waters that can be proven to users of water that can be proven to be put to what is called beneficial use, legal term. A term that has historically been equated to economically productive use. So hence the green circles on the brown squares in arid climates, hence manufacturing, industrial production, and so forth. In the last decade plus, the category of beneficial use has expanded to include ecosystem services, which is a great thing, and yay for that. So we're now in a conceptual world that is a little bit more open to expanded senses of values and utilities of fresh water. And then a third factor that shapes the ways of water in many regions are hydraulic technologies. And this could be a conversation in itself. There's a ton of innovation going on now in terms of water reuse, recycling, and so forth that I'll talk about a little bit more later. But I want to point out that it has been massive feats of engineering, and hydraulic engineering in particular, that have enabled water-intensive development on large scales. Agriculture, industry, moving the mouths of rivers such as the Mississippi, the flooding of the Delaware and Ashokan reservoirs and watersheds upstate in order to create the gravity-fed system that feeds water to New York City and surrounding areas. So this tends to apply to surface waters, which are the waters you learned about in 4th grade in the hydrological cycle, rain, lakes, rivers, and so forth. One of the things I love about living in the Northeast is the ability to follow these massive hydraulic systems. You can follow them in the West too, but I'll just speak to what we know here. So hydraulic infrastructure also includes the vast subterranean networks of pipes that both deliver fresh water to and take effluent away from our sinks, our showers, our toilets, our sewers. How many times have toilets come up this morning? Very exciting. Mid-November, World Toilet Day. Highly endorse celebrating it. There's a huge and intimate relationship between fresh water and sanitation. Again, a topic worthy of talk in its own right. And there are the pumps that move the water from underground tunnels to the tip tops of skyscrapers that we can see out the window. There are smaller scale pumps that spew storm water out of flooded basements, and pumps that delve deep into the earth to pull up water from a variety of types of spaces underground. It's this latter kind of pump that has been so effective that it's groundwater, not surface water on rivers or lakes, but groundwater, that has been the primary source of water for agriculture, for manufacturing, and for domestic use in the United States, and has amplified in the last 50 years, 30 years especially. What I want to point out here is a real wicked problem in the sociological sense for questions of sustainability, particularly of water. Because the extraction of water from many of these deep aquifers is not just a type of water withdrawal that participates in the hydrological cycle as we learned it pertaining to surface waters. Experts now refer to many forms of groundwater extraction as water mining, and the water taken from those aquifers as fossil water, in recognition of the fact that in many cases this water takes hundreds, thousands, in some cases 1 million years to recharge, as is the case, for example, with the Patapsco aquifer that undergirds part of Maryland. So here's a quote from a geopolitical writer named Brahma Chalemi in his 2013 book. "Tapping fossil water amounts to extraction of a virtually non-renewable resource that accumulated over thousands or even millions of years. They're practically non-replenishable, and it's thus like pumping oil." So one of the myths that environmental science and various forms of geologic, hydrologic modeling, especially the NASA GRACE satellites that have been really producing amazing images since 2010, indicates that aquifers are being depleted at a much faster rate than they are being recharged. And so this myth that needs busting, but that is still regnant in many of our imaginations, is that fresh water is renewable and is renewable on its own terms. In many cases, that is not at all true. So how do we think about water when we think about many of our water sources as functionally non-renewable? And that's even before we think about problems of pollution, contamination, microplastics, industrial effluent, atrazine from non-point pollution from farms in the Midwest, and so on. Waters then, I would argue, are not obvious. They are complex and contextual, even as they also carry consistent characteristics. So the ethics professor in me, the epistemology side of things, the how do we know what kind of thing water is question, wants to tell you that how we know what kind of thing water is, what we assume about it, is the result of certain kinds of dominant stories told in our society today. And fresh waters are therefore full of both continuities and discontinuities with one another. So this is an image that came from, I think, circa 2014, 2015, from the US Geological Survey. It's trying to show various proportions of the mass of the Earth terrestrially Then seawater is the bigger blob, the blue blob, blue sphere being a more technical word than blob. That's seawater. And then some of you may be able to see, if your eyesight's not like 15/15, you might not be able to see the tiny little blue dot on the right, which is supposed to represent the proportion of fresh water on Earth. The point here is that that tiny, tiny proportion of fresh water relative to the mass of the Earth, and certainly compared to seawater, is what sustains the possibility of all human and ecosystemic life on Earth. And so when we begin thinking about the non-renewability of some types of water sources, and we begin thinking about the stories that we have received from science, from economics, from many other realms about what kind of thing water is, we have not only a pragmatic functional problem about fresh waters and sustainability in an era of climate change, but we also have an ethical problem about how we understand fresh waters, who gets them, on what terms, by what mechanisms, and to what ends. This isn't really a recap. I took this from a prior presentation because I got back from Singapore less than 48 hours ago, and my friends, I was jet lagged yesterday. But globally, fresh water is not infinite. So 2.5% of all water on Earth is fresh water, and a much smaller proportion is actually surface water. Surface water is then minuscule relative to the image of the Earth that we have seen. It's renewable sometimes. Surface water tends to be pretty renewable, but deep aquifers are not renewable. And then fresh waters are unevenly distributed. The west of the US is not equivalent to the East Coast. When I came from the west of the US to the East Coast for grad school, I think the formal term is gobsmacked by how lush it is out here and how many trees there are just proliferating all the time and how you don't have to water lawns. What? This is bonkers. And then unevenly consumed. There's a whole thing we can talk about what water consumption means. Generally, in water policy wonk-type folks parlance, water consumption refers to waters that are used up in the process of industrial or agricultural or domestic deployment, so they can't be used again in a meaningful way in the watershed. Americans do tend to use a lot of water. By sector, about 72% of water globally goes to agriculture, which is a consumptive use because the water turns seeds into suppers. About 20% goes to industry, and that leaves about 8% of water for domestic purposes: cooking, cleaning, bathing, showering, frolicking, all of those kinds of things. And so what I want you to know from those statistics is that when we are thinking about global freshwater sustainability and engagement with particular kinds of projects, yes, it's important to think about individual water consumption for lots of reasons, but that is a drop in the bucket of overall water use. What we're really talking about are manufacturing, agriculture, and other highly consumptive types of deployments of fresh water. So I think the space where the continuities between what kinds of things fresh waters are, how those are universal, and the discontinuities, how they appear in a particular geographic region, these are where things get really interesting. And I think it's that dynamic space between continuity and discontinuity where you, as Green Team's scholars and solutions-oriented students, will find yourselves as you navigate the projects that you've been given on your teams this summer. So I'd like to ask you, in addition to solving those discrete problems, to do something more. I'd like you to bear in mind, it can be in the back of your mind even, the question, what is rendered visible, as well as what is rendered invisible or opaque by the way this project is framed? This is a feature of how humans look at the world in any kind of problem or situation. What we focus on both illuminates certain really important aspects of reality, even while it pushes to the side other important aspects. And so in your projects, constantly ask, what am I trying to achieve? What solutions am I looking for? How can I think outside of the box? but also ask, what am I missing by virtue of this project being framed in this way? Are there other frames that might be useful too? And how can those expand our consciousness and our thinking about this? This is important because fresh waters are slippery substances. They're wily solvents. They're wanderers and carriers of meaning that find the cracks and porosities in both our physical infrastructure and in our conceptual categories. In other words, waters always exceed the physical as well as the conceptual containers in which we try to shape them. So, high school chemistry, Lewis dot structure. Anyone? Okay, thank you. I love the polar tetrahedral vibe of the water molecule. Thought I was going to be a chemistry major. That didn't happen. And I also love this quote by the late social critic and theorist Ivan Illich, who says simply, "I shall refuse to assume that all waters may be reduced to H2O." What I mean by this is what I've been saying for the past few minutes, namely that there's not only one way of looking at what kind of thing water is. Waters are multiple. And actually, between the first edition of my book, Just Water, which came out in 2014, and the second edition, which came out in 2018, I did a kind of 180-degree shift in a revision. And that shift was from talking about global freshwater crisis, or fresh water in the singular, to talking about fresh waters and freshwater crises in the plural. This helps me to remember that while fresh waters are universal, they are also not uniform. Again, waters always exceed the physical as well as the conceptual containers with which we try to shape them. Here are what I see as, if not the 6 most important dimensions, then 6 really important dimensions of the climate-water nexus. The first is that water vapor is a really potent greenhouse gas. Now, it's not like an industrial-produced emissions fossil fuel kind of greenhouse gas in the way that methane or carbon dioxide or other molecules are. But nonetheless, water vapor has a really strong relationship to climate feedback cycles. You've heard of atmospheric rivers, probably if you've been following the weather news. Water vapor is a potent greenhouse gas and both contributes to and is impacted by dynamics of global warming. This often issues forth in water being a really potent vector for climate change or global warming in particular. So some of the dimensions that we see going on globally, and certainly we can see this in the Eastern Seaboard as well as various other places in the US, are drought, desertification, and aquifer depletion that are happening, again, in the US and worldwide. We see impact in agriculture because as areas get drier with drought or desertification, more groundwater is sucked up to water those crops, and the groundwater level depletes and can't be, generally isn't recharged in a meaningful timeline. This also impacts energy production. Fresh water is often, not always, but often a key part in the production of energy and cooling for thermoelectric plants, as well as manufacturing of semiconductors and various other kinds of materials that are crucial for other forms of energy production. And there are huge implications of the water-borne impacts of climate change for human existence, human movement, human suffering, human viability. So there's a lot to say here about the intersection between the social and environmental aspects of the water-mediated impacts of climate change, but a very, very visible one that is being felt by people all over the world is the reality that many people are forced out of their homes and livelihoods by changes in weather patterns and especially water. And so the phenomenon of global migration due to environmental causes is dramatic, is deeply consequential, and climate-induced migration is not currently, nor does it look likely to be, considered among the United Nations causes for migrants to receive refugee status. This becomes a political question, certainly an ethical and humanitarian one. Of course, there are also water conflicts. This has been hypothesized since at least 1984, when Boutros Boutros-Ghali said that wars of the future will be fought not over oil, but over water. There's been a lot of research since 2011 and 2014 indicating that water scarcity in particular is what is called a threat multiplier for various kinds of civil unrest and indeed armed conflict. But in addition to the legal or armed kinds of standoffs and conflicts that have happened worldwide over waters, there are also huge conceptual conflicts. Is water a fundamental human right, primarily, or is it an economic commodity? And how do those two paradigms intersect with one another? Some sum up quotes. Climate change is all about water, said Zafar Adil, then I think it was 2011, the head of UN Water. And then a little bit more forcefully, Travis Huxman, who used to direct Biosphere 2 in Arizona, said that water is the hammer with which climate change will hit the Earth. So among the ways that climate change gets envisioned, sometimes it's really nebulous and vast and confusing. But when you take water as the primary vector for climate change's impacts, it gets really real, really fast. And that's why I like this quote, destructive though it is. Water is the hammer with which climate change will hit the Earth. So, in the next 10 or so minutes, I'm going to conclude by offering some thoughts on ways that we can view fresh waters, or that have become prominent on a global scale in the last 10 or so years. Actually more, we'll just call it 20 years. And I'm calling these apertures partly because I wrote an article in 2018 that talked about different apertures for viewing fresh waters and the kinds of what is rendered visible by looking through certain lenses and what is occluded by looking through some of those lenses. But also the reason that I'm talking about apertures now is that on your projects, you're going to have apertures for regarding the outcomes, the contexts, the goals, and the methods by which you try to solve these problems. So here are three. One is viewing fresh water as a property, a type of property. This goes back to what I was saying in the very beginning. A natural resource, something that can be extracted and deployed for use, or a commodity, something that can be bought and sold. This is the story of water that tends to reign in legal, governmental, and commercial contexts in places like the United States. So property, resource, commodity. That's the first aperture. Second aperture, what kind of thing is water? Well, since 2010, it has been viewed as a fundamental human right. A UN convention was passed in 2010 that articulated that fresh water should be considered a universal human right because it's fundamental to the achievement of all other rights. If you don't have fresh water, you can't do anything. And that's really important globally as a kind of moral reframing about what sort of thing water is and who should have access to it. But it's also telling that a number of countries, Canada, the United States, a number of others, have not signed on to this idea of fresh water as a human right. That's a whole nother topic and talk, but it means that when water was shut off from low-income residents in Detroit in 2014, 2015, and entities tried to sue the government for breaching the human right to water, a judge in Michigan threw out that case, saying this concept does not have standing in the United States. So there is no federal right to water for humans or ecosystems in the United States. There are some state-based approaches that might be interesting for you to explore. More recently, in 2017, New Zealand, Aotearoa, acknowledged with the Maori tribe that the Wanganui River in particular was not just a river in a Western political economic formation, but also has the legal status of person. That is, an entity deserving of its own integrity and rights and being treated as a whole, not as a parcelable unit. Now, the water negotiators for the Maori tribe were very explicit, saying, it's not that in our culture we think of water as a person in the sense of human, but we think of water as an entity to which we are related, one to whom and to which humans have responsibility. And the language of person was the most amenable Western category to deploy in the negotiation over what kind of thing water is. It helped to expand environmental understandings. A lot of people got their socks in a kerfuffle about that and were like, what? Water can't be a person? To which I would just say, if a corporation can be a person, why shouldn't water also be? A final term that I'd like to offer to you is one from geographers that was developed in around 2008 and has been used in a range of contexts since. It's the idea not just of hydrological cycles, but hydrosocial cycles. So this is the idea that waters obviously do not operate independent of human societal influence, but rather it is also very much our human institutions, governments, corporations, cultures that help to determine how waters flow. Who gets to withdraw them? For what reasons? Who benefits? And who bears the burdens? So, to your language of hydrological cycles, now you can add hydrosocial cycles. And as I mentioned casually a few minutes ago, I'm just back from a really wonderful research trip that involved going to Singapore. I have wanted to go to Singapore since like 2010, people. And so last fall, when I got an email saying, hey, would you be willing to come give a talk and have a conversation? I actually thought it was a joke. With trepidation, I wrote back, I was like, do you mean in person? For real? And they did. And let me tell you, that is a long flight. Definitely my longest ever. So I want to conclude with some reflections on hydrosocial cycles and values in Singapore. Not because I think the United States is Singapore, but because I think it has helped me to think outside of the box and in different ways that are not just like professor conjecturing about whether water is a person, but is also very much enacted in the societal organization of this particular nation state. So Singapore has about 5.5 million people in an area roughly the size of the greater San Diego area. 440 million gallons of water a day are used in Singapore, with approximately half going to industrial uses. So of course, the US, by contrast, is far bigger, uses more water for domestic, industrial, and agricultural purposes. Singapore is a top-down planned society with strong authoritarian tendencies, which the US is not. And Singapore also employs a 100-year horizon for thinking about freshwater infrastructure, which the United States does not. But again, I want to present Singapore as a case study just for thinking about, not necessarily because it's the best or because it's an exact cognate, but because I think the watershed scale of it can be instructive for thinking about projects in New Jersey and elsewhere this summer, even with the very real discontinuities I just mentioned. So there are four main types of water inputs, freshwater inputs in Singapore. There's surface water, and relative to the entire size of the island, about 2/3 of the island is conserved for watershed management. Water also comes from water transfers from Malaysia, and Singapore has set up a water purification plant in Malaysia that they then sell some water back to Malaysia as part of the separation agreement from Malaysia that happened in 1961. Singapore, like many other places worldwide, does a lot of desalination of ocean water. And then very interestingly, there is new water, which is a technology that came online in the early 2000s and has really amplified since then. New water is reuse, not just recycling, but full-on reuse of what they call used water, and we in the US and other places worldwide might call brown water or sewage water. So it's toilet to tap. Fourth toilet mention. This is really fascinating because not only have they been leaders in the technology of new water or a fully reused water, but they have also been central in thinking about the kinds of uses to which this super clean, it undergoes flocculation and filtration on a number of scales. It undergoes UV treatment and ozonation, as well as reverse osmosis, and then a compound of sodium hydroxide is put back in to soften the impacts on pipes. But what that new water is used for is generally industrial uses, such as semiconductor production. And this is really important because water used in that kind of industrial production has to be both really clean and relatively cold. And so thinking about how to support the growth of certain kinds of manufacturing or technological development, which will only be increasingly demanded with the increased desire for green technologies, is a really interesting kind of case study to think through with new water. New water is sometimes used, put into some of the reservoirs and mixed in with natural water. And by 2060, Singapore expects the water supply to be 30% desalinated and 55% new water, leaving only 15% to be water from Malaysia and the surface water. Okay. So this, to me, prompts some crucial questions that also link to what I was talking about earlier. I want you to look in your groups, not that you really have to, because it's not like I'm going to be grading you, but I'm going to encourage you to look at what are the main uses and reuses of water in the region you'll be working in. What does the subterranean water infrastructure look like? Are there ways to rethink and repipe, say, used water, whether that's stormwater or brown water or sewage water? What institutions could invest in such infrastructure to make it happen? Corporations, government, green finance? I'd also love to hear your thoughts, when you come back in August. What are the goals of water provision and where do you see water showing up in your projects? And then I'd love to hear you think about what a 100-year plan for water integrity would look like in the region or the project you're working on. As you're probably aware, in the US, we have a very short time scale that we operate on. Election cycles, fiscal quarters, sometimes the academic year. Think bigger. Think 50 years. Think 100 years. What would that look like? That's a slide about how temperature has increased in Singapore, and no one's arguing against climate change. The end. Okay. Conclusion. LA, this is a picture again of LA at night. It's the one with which I started. So my unhumble concluding exhortation to you all, you awesome humans, is that I invite you to think broadly and without restraint. What could the US look like if we invested considerable money and human energy into water resources, infrastructure like sewage systems, reuse technologies, as well as public awareness and civic attunement? I think there's really not a setting quite like this one, where you as students with the knowledge from your disciplines can partner with corporations and government and nonprofits to think through some of these questions. What kinds of goals do you want to achieve, both for the project that you've been assigned and for the world that you perceive? What kind of civic and corporate responsibility do you want to encourage? What would it look like for waters to flow ethically for maximal common good, for the good of students in low-income schools, as well as public parks or ecosystems, for the good of free water fountains and the human right to water, as well as sewage systems, for wise use of land and water broadly understood? How our institutions mediate water, I think, is a measure not just of how we value water, but also how we value life and our relationships with one another. Because without water, we are, in fact, utterly unrecognizable. And so while this all may sound heady, it's perhaps the most practical ethical question that anyone can ask in an era of climate change. So I ask you this summer to notice how water is always so many things. Yes, it's treated as a commodity or a resource, but it's also a vital entity that mediates all forms of human relations. And I'm very excited to see what role you all might play in achieving not just financial value for shareholders, but existential value, embodied value, watery multiplicity for all who live in a given watershed. So again, I'm asking you, as you work on your projects, to go beyond what is asked, to imagine waters differently, to see what is possible and ethical, and what is distinctly yours to make visible to broader society. I'm really excited for you. I wish you the best, and go for it. Thank you.